Okay, I can start now.
Okay, I'm start now. Thank you.
Okay, before I give a presentation today, I will introduce myself firstly. My name is Wai Tianxiang, and you can call me Brian. And I'm from Department of MEEM, and I'm a PhD student. Okay. And first of all, it is necessary to talk about the intended learning outcome of my presentation. So by the end of the lecture, you are able to identify the concept of computer vision and can explain the principle of the stereo computer vision and generate some examples of applications. I list the outline of the presentation below, and I will talk about the basic concept of computer vision as an introduction. Then I will talk about the principle of stereo computer vision and its applications. And finally, I will draw some short conclusion. Okay, let's start. First of all, before I talk about computer vision, I want to introduce about human vision. Human vision is a process of discovering something in the real world and find where it is and what it is. So the process is that we catch some scenes with our eyes and transfer our signal, some biological signal, to our brain and get some visual perceptions. Similarly, computer vision is very similar with human vision. We use camera and computer instead of our eyes and brain respectively. So we can get the scenes with the cameras and transfer the electricity, the electrical signal to the computer and get what we found and where it is. Until now, everything seems easy, but there is some problems. Suppose there is a rain and there are 2 points on the rain, and after the camera catch the rain, there is a projection, P, located on the screen. And the screen is in 2-dimensional space and the point is in 3-dimensional space. So there is something miss. So here's the question: why we use stereo vision? So we cannot find out this point. We cannot know P is represented for A or B. So there is a depth information loss through this figure. So let's think about human vision again. We watch something, we look at something with our eyes. So why not we use 2 cameras to catch one single scene? So if we use 2 cameras, we can observe point A and B by we can distinguish point A and B with the left-hand side camera, even though the right-hand side camera cannot find out which one, A or B. So this is the some basic principles of stereo vision. Also called triangulation algorithm. Actually, the triangulation method is not a new thing. It was investigated by a Chinese mathematician, Liu Hui, 200 years ago. So it's an old method. Let's go further. Let's go further in the triangulation method. As we can know, suppose we are going to measure the point A in 3-dimensional space, and we get O1 and O2 is the optic center of the 2 cameras. According to basic mathematical concept, 3 points can construct a plane called gamma here. So we can consider the triangulation problem as a geometric problem in the plane gamma. So the depth Z can be calculated by the equation equation 1, here is 1. And T represents the distance between the two cameras, and XR and XL represents the distance between the optic center and the projected point, P1 and P2. And F represents the focal length of the camera. So here I will give out the first assignment of this lecture. Actually, it's not a very difficult problem, so I'll give you some tips about the lecture. Please notice that the triangle in the gray color is similar with the triangle in the green colors. So I think it's not a difficult problem for you guys. Okay, after talk about the principle of the stereo vision system, I will pick up some application of this system. So this is the, I think you are familiar with this picture. Is the Mars exploration rover robots. So I have a question now. So where is the cameras on the robot?
Top?
Yes.
Yes.
Yes, the camera. Here, actually, this is two cameras. It's a stereo vision system. So you can see, as you can see, this stereo camera can guide this robot moving on the Mars. Here is some results from the paper reference 2. The robot can detect a rock in front of itself, and how far is it, and how it can avoid the rocks. And here are some other applications. For example, is camera tracking or surveillance. And as can be seen in the figures, the stereo vision system tracks the people moving in a shopping mall. So it's a very important application for security monitoring nowadays. Here I give you the second assessment today. Please design a simple application of a stereo system. It is actually it's not necessary to design a complex one. Just draw out some photo pies or what you think is okay. And in order to remind our memory, I should draw some conclusions here. So first of all, I mentioned the concept about computer vision. The computer vision is a science and technology that let the computers observe or analyze what the camera gets. And the principle of stereo vision is triangulation. And finally, I talk about something application like tracking or surveillance and robot navigation. And if you want to learn more about computer vision, especially in robot vision, you can see the reference book I list below. The name is Computer Vision, a Modern Approach. So, thank you.
Okay, questions?